The 1869 periodic table by Mendeleev in Russian with a title that translates an experiment on a system of elements based on their atomic weights and chemical similarities. So you can see this is the form of the ancient periodic table. Okay, bentuk periodic table yang lama. So from this periodic table, we can see that there are not many elements in the periodic table, of course, and also it is quite difficult for us to identify the group, the period, and the block of these elements. So in this video, you are going to study the current periodic table and how to identify the group, block, and the period of the elements from the periodic table itself and also from their electronic configuration. So let's watch this video. At the end of the lesson, students should be able to indicate period, group, and block for specific element, specify the positions of metal, metalloids, and non-metal in the periodic table, and also deduce the position of elements in the periodic table from its electronic configuration. So by the end of the video, you will be able to identify the group, period, block, and also the classification of this element as metal, metalloid, and non-metal based from their electronic configurations. The periodic table is a table that arranges all the known elements in order of increasing proton number. So if you are still in doubt, how does the scientists before arrange all the elements in the periodic table? So here is the answer. They arrange all the elements in the periodic table according to increasing proton number. This is the current format of the periodic table, the current version of the periodic table. So if you compare with the one in the Mendeleev form before, so of course we can see that the current form of the periodic table is more interesting, very neat in the arrangement, okay, and easy for us to identify the group, periods, and such. Okay, so from this periodic table, can you identify which one is group, period, and block? And I am very sure that you could answer all these questions as you have learned this basic concept in secondary school. So in this level, we are going to study some more. Okay, what we can do or what we can relate with the group, period, and block, and how could we associate the knowledge of the electronic configuration in order to find the group, block, and period from the periodic table. Because later in the exam, in order to find the group, block, and the period of certain element, of course you cannot refer to this periodic table, because you cannot bring this form of periodic table into the exam. But by knowing the electronic configuration of the certain element, you must be able to find its group, period, and block. So this is the thing that we are going to solve for this level. The vertical column in the periodic table is referring to group. So we have group 1 until group 18 in the periodic table. So this is group 1, group 2, transition metals group starting from group 3 until group 12, group 13, 14, 15, 16, 17, and 18. So basically, elements that lie in the same group will have the same number of valence electron. Okay, elemen yang berada pada kumpulan yang sama akan mempunyai valence electron yang sama. So what is valence electron? Bilangan elektron di orbital yang paling luar. Okay, so for example untuk group 2, all group 2 elements will have 2 valence electron in their valence shell. And for group 17, for example, all of these elements will have the same number of valence electron, that is 7 valence electron. So from the group itself, you can identify the number of valence electron for each of the group. And we can say that for the elements that have the same number of valence electron, so basically they will have similar chemical properties, even though their physical properties will a bit different. So apa maksudnya same chemical properties tu? Maksudnya the way they react in chemical reaction, the way they form the bonding, for example, will be the same. For example, for elements in group 2, in order to form the bonding, they tend to release their valence electron, okay, in order to form the ionic bonding. So that is one example of the chemical properties. And I guess you must be wondering, for example, for group 17 in this halogen and group 7 in these transition metals, how many valence electron do they have? So for the transition metals group 7 here, they will have 7 valence electron. And for the group 17 here, for the halogen gases, they also have 7 valence electron. But how do we differentiate the group of these 7 valence electron elements for halogens and transition metals? So, we will discuss about this in the next slide. Periods are the horizontal row in the periodic table, and the elements in this row are arranged in order of increasing proton number. So here we have period 1 until period 7 in the periodic table. So as you can see, in period 1 we just have 2 elements that are hydrogen and helium. And for period 2 we have these 8 elements. Period 3, period 4, 5, 6 and 7. So basically we have 7 periods in the periodic table. So for the period 1, for example, between hydrogen and helium, how do we know that these two are located in the same period? Basically, you can see from their electronic configuration. So for example, for hydrogen, its electronic configuration is 1s1. And for helium, its electronic configuration will be 1s2. So how do we know that these two elements are located in the same period? Is by looking at this n, principal quantum number. And the same thing goes to the other elements in the other period as well. For example, for elements in the period 3, we have sodium until argon. So for this sodium and argon, for example, how do we know that those two are located in the same period? So the answer is you can simply refer to their electronic configuration. So by looking at the electronic configuration, you can refer at their valence shell, and they should have the same number of principal quantum number, same value of principal quantum number n in their valence shell. So that shows that they are located in the same period. So elements in the same period will have the same principal quantum number at their valence shell. Elemen yang berada dalam period yang sama, okay, contohnya kita bezakan antara sodium dengan klorin, contohnya sekarang ni. So bila awak tulis electron configuration for sodium dengan klorin, you boleh tengok pada valence shell untuk kedua-dua atom itu nanti, dia punya nilai n, okay, that is principal quantum number will be the same. Cuma yang membezakan mereka adalah sodium berada pada block S. So maksudnya in its valence configuration, dia akan ada 3s. Dan untuk klorin, since klorin dah terletak pada P block in its valence configuration, so you akan observe 3s dan juga 3p orbital. There are 4 main blocks in the periodic table. We have S, P, D and F block. So basically for elements that lie in block S and D, in order to find their group, we can find directly from their number of valence electron, because number of valence electron equals to the group itself, okay, for elements in block S and block D. But for element in block P, in order to find the group for that element, from the valence electron you have to plus with 10. So here are the 4 main blocks in the periodic table. So here are the S block, including the one up here, that is helium. And then we have P block on the right side of the periodic table. In the middle here, we have the D block for transition metal atoms. And at the bottom here, we have F block. Before we go to period, group and blocks in details, let us see what is valence electron. So valence electron is or are the electrons that is found on the outermost orbital of an atom and can be shared or taken in a reaction. The number of electrons in the outermost shell gives the total number of the valence electron in that element. So let's take calcium as the example. So calcium has 20 proton number, which equals to its number of electrons. Okay, kerana it is a neutral atom. The number of proton will equals to the total number of electrons. So from this proton number, you can write this electronic configuration. So from here, we can find out that the last configuration here, we call it as valence configuration. So in this valence electronic configuration, we can find the valence electron, which is 2. So these 2 electrons here, we can find in this outermost shell or valence shell. So electrons that are located in the valence shell will be known as valence electron. So the one yang I bulatkan ini adalah valence configuration
yang kita ambil daripada valence shell.
So, 2 dekat atas ini yang kita panggil sebagai valence electron. So, valence electron adalah jumlah of electron yang located pada outermost shell ataupun valence shell,
iaitu shell yang paling luar.